Welcome to UrbanPlan, a powerful WebGIS platform transforming urban planning in Nepal. Designed for sustainability, UrbanPlan empowers urban planners, policymakers, and communities to make data-driven decisions for a better future. With interactive maps, advanced spatial analysis, and automatic tools, Urban Plans brings Nepal's geospatial data to life. In this video, we will explore the technology behind Urban Plan, the tools used to build it, the process that brought it to the life, and the users it serves. Let's dive in. Urban Plan is built on a robust open source technology stack designed for performance, accessibility, and scalability. It breaks it down across its uh, three-tier architecture. Urban Plan's interface is crafted with HTML for structure, CSS for modern responsive designs, and Leaflet.js for interactive mapping. Leaflet.js lets users toggle between OpenStreetMaps, CartoDB dark matters, and Esri world imagery, ensuring flexibilities for different planning needs. Chart.js powers our visualizations, creating responsive bar chart to compare infrastructure across provinces. The heart of urban plan lies in JavaScript for dynamic interaction. Top.js, a powerful geospatial library, enables complex operations like buffering, point-in polygon checks, and density calculation right in the browser. The Fetch API ensures seamless data retrievals from our backend with robust error handling for reliability. GeoServer, hosted at localhost, manages Nepal geospatial data, delivering raster tiles via WMS for fast visualization and GeoJSON via WFS for analysis. From provinces to schools, GeoServers organize data in the urban planning workspace, making it accessible for real-time insights. We have used this stack because it is open source, lightweight, and scalable, ensuring urban plan is cost effective and adaptable for Nepal's urban planning needs. Some of the tools and software used for making these are Visual Studio Code, Visual GitHub, and PostGIS, PJAdmin, and Mapbox Studio. About us, Urban Plan is a passionate initiative driven by a dedicated team committed to transform urban planning in Nepal through innovative geospatial technology. Our mission is to bridge the gap between geospatial data and urban planning by providing an accessible interactive platform. Our vision is to integrate cutting-edge technology like AI and GIS with community-driven planning. We aim to set a global standards for urban development. Our team contains front-end developer as Rajan Paudel, back-end developer as Susam Srestha, project manager as Sagar Upadhyay. This is simply the mini project interface, which contains at left the sidebars which have the administrative layers and infrastructure layer. At the right there is a setting box which contains different types of spatial operations. In this urban plan we have three base maps: OpenStreetMap, Car2DV, Dark Mat, and ISRI World Imagery. We generally use OpenStreetMap, and in our overlay layers we have administrative layer, province, district, and local level. These all data are on GeoServer. If we check the province, it will give the province save file, map to province layer on the map. Similarly, when we check the district, it will give the district on the map. Similarly, for the local levels, it will display the uh, layers on the map itself. Similarly, if you want, we have three infrastructural layers which contain school, hospital, and road. We will apply the spatial function and attribute functions on these six layers: province layers, district layers, local levels, schools, hospitals, and roads. If we click the school, then it will display the schools on the map. For hospitals also, it will display the hospitals data on the map itself, and the road connections will also display on the map. We have used tiles on web server, and if you don't want these layers, we can click this button and the side bar will go close this. And now we will apply the spatial functions. If we'll click here and select buffer selected hospital, if you select the hospital, I will select Nepal hospital post, then it will create a 5 km buffer around hospital, Nepal Health Post Hospital. If you want buffer on all the hospitals, then we will create all, select all and create OK. Then it will create a buffer on all the hospital present in Nepal. Some are intersecting also. Now we can clear all these from this another special tool, clear function tools. It will clear all the buffers which have just now created. Now another function is it only filters the pharmacy from the shape file. Displays the pharmacy present in the shape file. If you want clear, then you will clear all the datas. Then next tools is count school by province. It will count the number of schools in each province and display a pluralist map after the count. Now the alert message has give all the school total number of school present in the province by using the intersection features. Now it will display the pluralist map for each province with legend at the left corner. If we want to clear this, then we will do clear. Now next function is the road density. It will measure the load density, calculates road density for a selected province, highlighting the province light blue field and intersecting road red lines. We can select the province we want. We will select Bagmati Pradesh. Then when we calculate the road density, it will display the province in light blue field and intersecting roads in red lines. It has gave the road density for Bagmati Pradesh. Area is equal to in kilometer square, roads in kilometer, density in 0.2867 kilometer by kilometer square. Okay. Then it have displayed the Bagmati province in black and red the roads data inside the Bagmati province. Now we can use this clear for clearing all the mess created before. Now we can use another special tool which is filter school by district. This function filters school located within a selected district polygon. It selects the school within a selected district polygon. Now we will choose Bhaktapur district and apply filters. Then it will give the schools within the Bhaktapur district only. Next special tool is the chart, which will show the total number of school present in each provinces and total number of hospital present in each provinces. In this chart bar, we can know that in province 1 we have only 1241 schools, and simultaneously the highest number of school is in province number 5. Similarly, for hospitals, the highest number of hospitals in is in Bagmati Pradesh. It will show the highest number of hospitals present in the that polygon. Next one is which allows user to click anywhere on the map to create a 5 kilometer buffer, counting schools and hospitals within it and displaying markers. It toggles a click to buffer mode via toggle click buffer mode, uses the torf.js to create a buffer and checks for contained features, adding results to click buffer layer. In this buffer, it contains 25 schools and 28 hospitals present. Thank you. Our mini project, the urban plan, adopts a three-tier architecture to ensure a modular, scalable, and efficient system design. This architecture divides the application into three distinct layers: the presentation tier, the application tier, and the data tier, each with specific responsibilities that enhance maintainability and performance. This is generally the uh, presentation tier, which is on web browser, which opens on open layers. And similarly, there is a middleware, or generally known as, it is also known as web server, which works as the middleware. And the next layer is data tier. And the next tier is the database tier, which is linked by PostGIS, which is linked by PostGIS. Some of the codes used are these: HTML for structures, CSS for styles, and JavaScript for responsive design. Main is main.js helps for the main web page loading, for drop downs of the districts, provinces, and many other. And tools.js help for the creating different spatial tools. It will create the buffer on map, create hospitals buffer, filter pharmacy from the database, create maps, chloroplet map, it will create the density, calculate the road density for selected provinces, filter school by district, it will filter the school by districts. This will show the charts for the total number of school present and hospital present in provinces, and at last there is clearing all the layers from the map. It will clear all the layers from the map. These are some of the HTMLs used for visualizing. Thank you. The intended users of urban plan are the urban planners, the professionals responsible for designing, managing, and implementing urban infrastructures and land use strategies in Nepal's cities, towns, and rural areas. They work in government agencies, consulting firms, or local municipalities. Policymakers and government officials, decision makers in national and local government, including ministries of urban development, educational, health, and transportation, tasked with creating policies, allocating budgets, and planning infrastructures. GIS analysts and developers. Why they use urban plan? It is the data access, learning resource, debugging supports, and many others. NGO leaders and community organizational, researchers and academics, scholars and educators studying urban development, infrastructure distribution, spatial equity, or geospatial trends in Nepal, often in universities or research institutions. Urban plan is tailored to this group because they are key stakeholders in Nepal's urban development ecosystem, each with unique needs that the application addresses. Diverse need, accessibility, actionable insights, scalability, contextual relevance. Thank you.